In this video, I'm going to be covering practice problems from the Trigonometry Final Exam review. In this problem, they want us to find the exact values, so no rounding. If you think about 5/4 pi, where that is, we have pi over 4, 2 pi over 4, which is pi over 2, 3 pi over 4, 4 pi over 4, which is 1 pi, and then 5 pi over 4. So to get down here, we would need to go over into the negatives and down, which is negative. And remember, the fourths are always square root 2 over 2, square root 2 over 2, or they're negatives. So the coordinates are negative square root 2 over 2 and negative square root 2 over 2. Of course, x corresponds with the cosine and y corresponds with the sine value. All right, what about pi over 2? To get up here on the unit circle, we would go over 0 up 1. So the coordinates are 0, 1, and so the sine value here is 1. So we're just going to substitute those in. Sine of 5 pi over 4 is negative square root 2 over 2, and sine squared just means we're multiplying it by itself, the sine of pi over 2, which is 1 times 1, or 1. So our final answer here is just going to be negative square root 2 divided by 2. We don't want to round that because then it wouldn't be an exact value. This question is asking about the graph of this cosine function. They want us to find the amplitude, period, and phase shift. Recall that the amplitude is the absolute value of A, and A is the number in front of cosine or sine, in this case cosine. So it's just the absolute value of 2, which of course is 2. Next, we're going to find the period. When we're dealing with cosine or sine, we know that the equation to calculate the period is 2 pi divided by b, and b is this number that's in front of x. Period is 2 pi divided by 3/4, which is the same as 2 pi over 1 times 4/3, or 8 pi divided by 3. The last thing is to find the phase shift. Your phase shift would be the c value minus c is the formula, and that's the thing subtracted from the x, but there's nothing there. So our phase shift is 0, meaning the graph does not move left or right. If cosine t equals 6/7 and sine t is greater than 0, find sine of t. So this is just telling us that sine of t is positive, and they want us to find sine of t. Since 6/7, we could tell this isn't something that they're talking about on the unit circle. Those are not values that we find on there. So we need to use the formula cosine squared t plus sine squared t equals 1. And we'll substitute in what cosine t is, 6/7, and we square that, and we bring down sine squared t equals 1. Then we calculate the 6/7 squared. Next, we will subtract that from both sides of the equation, which is the same as 49/49 minus 36/49 on the right. So we're going to get sine squared t equals 13/49. At this point, to get sine t from sine squared, we will take the square root of both sides, which is the same as the square root of the numerator, divided by square root of the denominator. Typically that gives us a plus or minus, but we know that they're wanting us to only find the positive sine t value. So sine of t equals square root 13 divided by 7. That's the exact answer. The next question you can just type right into your calculator, as they're asking us to find the approximation rounded to 4 decimal places. So remember that arctan is the same as tangent inverse on your calculator, which is often the second function of the tangent button. So you'll just type in sine, left parenthesis, tangent inverse, left parenthesis 2, and then right parenthesis, right parenthesis. And it should pop out the value rounded to 4 decimal places of 0.8944. This question has to do with our identities. Rewrite the right side of the equation in terms of cosine x and sine x, then simplify. So the left side's going to stay the same, and the right side we're going to change tangent x to sine x divided by cosine x. And since cosecant is 1 over sine, we will change cosecant x to 1 over sine x. At this point, we realize we have a sine x and sine x. We can cancel those out. That leaves us with 1 times 1 on the top divided by cosine x times 1, which is cosine x. And because secant x is defined to be 1 over cosine x, we can just change this to secant x to match the left side. So what have we determined? We have determined that this up here is an identity, meaning the left side is identical to the right side. Next, we're being asked to simplify this expression. It helps to keep in mind the unit circle values. So at pi over 4, our values are square root 2 over 2, square root 2 over 2. So the sine value is square root 2 over 2. We could substitute that in. For the one on the left, it might be helpful to combine these fractions. So I'm going to find a common denominator, multiply by 3, multiply by 3, and multiply by 2, multiply by 2. That's going to give me sine of 3 pi divided by 6 minus 2 pi divided by 6, and that would simplify to 1 pi over 6, which is pi over 6. And its coordinates on the unit circle are square root 3 divided by 2, comma 1/2. So the sine is 1/2. So this is our final answer unless we want to factor out a 1/2, and then we would get 1 minus square root 2 inside. This problem also wants us to find the exact value for cotangent negative pi over 3. So where is negative pi over 3? Remember, negative rotations go downward. Since pi over 3 would be about here in the positive, then it would be just a reflection over the x-axis. So what are the coordinates at pi over 3? It would be 1/2 comma square root 3 divided by 2. So in this case, it'd be 1/2 negative square root 3 divided by 2. But they want us to find the cotangent of that, which is basically x divided by y. The x coordinate here is 1/2. The y coordinate is negative square root 3 divided by 2. And since division is multiplying by the reciprocal, we can multiply by the reciprocal, and we would get negative, if we brought it to the numerator, the negative in the denominator, 1 over square root 3. But we're not allowed to leave a square root in the denominator of a fraction, so we will multiply by that same square root divided by itself, and we would get negative square root 3 divided by square root 9, which is 3. So final answer is negative square root 3 divided by 3. We next have to find all the values of t that make the equation true, and to use n for the variable on our multiple answers. So secant of t is 2. In order to figure out what t is, we can do arc secant of both sides of the equation. That will cancel out the secant and give us t on the left side. So what does this mean? We can read it as the angle whose secant is 2. Remember, secant is 1 divided by cosine, and 1 divided by a half would be 2, where the cosine would be a half. Where would there be a cosine value of a half? And that would be at 60 degrees, or pi over 3. We would have the coordinates 1/2 square root 3 over 2. That would lead to the secant 1 over cosine being 2. We need to find all the values in which it would land here. So that's when we do those multiples of 2 pi. Are there any other values on the unit circle for which we have a cosine value of a half? And there would be one down here, meaning it would be at 300 degrees or 5 pi divided by 3. So this would also be cosine of a half. Its y-coordinate would be a negative though. We have found the two values for which cosine is a half, meaning the secant is 2. Pi over 3 and 5 pi over 3 plus 2 pi n and plus 2 pi n, where n is the number of rotations, positive or negative, around the unit circle. Next, what is the angle of elevation of the sun when a 70-foot flagpole casts a shadow 56 feet long? So for these type of problems, we want to form our right triangle. Since they're talking about the angle of elevation, we know that they're talking about this angle here facing upward. In terms of opposite, adjacent, and hypotenuse, the 70 is the opposite side, and the 56 is the adjacent side. So when you think of SOHCAHTOA, the two values opposite and adjacent are in the t tangent function. So we know that tangent of the angle x equals 70 divided by 56. So how do we find x? To get x alone, we will do tangent inverse of both sides of the equation, and you could put that into your calculator. X equals 51.3 degrees. Please comment below if you found this video helpful, and subscribe for the next video in this series. Thank you for watching.